Okay, these are from 6.1 in the pre-calculus textbook. I believe it's on the law of sines. You know you can use the law of sines whenever you have both A's, both B's, or both C's. In this case, I have both A's. So I'm probably going to use the law of sines using sine of A over A. I don't know either value for B, so I don't think it's appropriate to use that one. So I might make this equal C over the sine of C. So let's fill this in and see what we can solve. I don't know the angle C, but I do know side A is 10, angle A is 63 degrees, and side C is 8.9. So hopefully I can find angle C using this information. So I get 10 times the sine of C equals 8.9 times the sine of 63 degrees. So I get the sine of C to equal 8.9 times the sine of 63 degrees divided by 10, or approximately something I'm going to get on my calculator. Okay, I punch this in my calculator. I got the sine of C to equal 0.79299. So to get rid of the C, to get rid of the sine, you're going to take the arc sine. If you do it to one side, you do it to the other side. So that'll tell me what angle C is if I take the arc sine of that value. I'm using stack operations, so I should be pretty accurate on my rounding. I want arc sine of 0.79 number, and I get 52.466. 52.466. The degrees are supposed to be to the nearest degree. Angles are to the nearest degree. Sides are to the nearest tenth. So am I going to call this 52 or 53 degrees? C is going to be 52 degrees. Now you can do, you can find angle B because you know the total in a triangle is 180. 63 degrees and 52 degrees would add to give me 115 degrees. If I subtract that from the total in a triangle, that leaves me with, I believe, is it 65 degrees? I think that would be it. So now I'm going to do A over sine A, and now I'm going to do B over sine B. So again, I'll set it up and we'll fill in the values. Okay, do I know side A to be 10 and do I know angle A to be 63 degrees? Do I know side B? No. Do I know angle B? Well, I know a rounded version of it, 65 degrees, which is the best I can do right now. I could call it 65. I could be more accurate, but I'm going to leave it like this. So what do I end up with? I get B times the sine of 63 degrees equals 10 times the sine of 65 degrees. So B is going to equal 10 times the sine of 65 degrees divided by the sine of 63 degrees. And I'm going to punch this in my calculator. 10 times the sine of 65 degrees and divide by the sine of 63 degrees makes B, I believe, to be 10.171. To the nearest tenth, that's going to be 10.2, right? So B is going to be 10.2. Now again, I always tell you to make your last check. What's your biggest angle? Is it opposite the biggest side? What's the smallest angle? Is it opposite the smallest side? So we have our solutions for 19. Okay, let's look at number 23. Again, I know both A's. So I'm going to do A over sine of A, but which one do I want to use now? Why would I use B and not C? Because I know something about one of the B's. I don't know anything about the C's. Angle A is 30 degrees. Side A is 10. Side B is 40. I do not know angle B. So I'm going to cross multiply and solve. 10 times the sine of angle B is equal to 40 times the sine of 30 degrees. The sine of angle B is going to be 40 times the sine of 30 degrees divided by 10, which basically is 4 sine of 30. What is 4 times the sine of 30? 2, so hang on, that can't work. Give me 1 second. Let me make sure I wrote this right. Okay, A is 10, angle's 30. B is 40, I need to know angle B. 10 times sine B, 40 times sine 30. Then you would divide by 10. And I get this to equal 2. And if I was to do the sine of B equals 2, I know there's an issue already because the biggest the sine gets is 1. The smallest is -1. If you were to punch this in your calculator to get rid of the sine, you take the arc sine, it's probably going to give you an error because you can't take this arc sine of anything bigger than 1 or smaller than -1. So I'm going to assume this is not a triangle. Bear with me as I check in the textbook. So correct, it was not a triangle is the answer to number 23. Okay, after 23 we're going to try 25. Again, I know both A's, so again I'll do A over sine A. Do I want to use B or do I want to use C? B, because I know something about the B's. So we'll fill these in and see what we can do. Side A is 16, angle A is 60 degrees. Side B is 18, and I need to find angle B. So I filled everything in. That gives me 16 times the sine of angle B equals 18 times the sine of 60 degrees. So the sine of B is going to be 18 times the sine of 60 degrees divided by 16. Hopefully this value is between -1 and 1. Otherwise, it would not be a triangle like the previous question. 18 times sine of 60, take that number, divide by 16, and I get 0.97427, 97427. So to get rid of the sine, you take the arc sine. So you're going to get the arc sine of 0.97427. Again, the more decimals or digits you use, the more accurate you will be. I'm using the stack operation, so I get about 23-digit accuracy on my calculator. So I want to do arc sine of that previous number. In degree mode tells me that angle B is going to be about 76.97. So to the nearest degree, we're going to call that 77 degrees. So that's 77 degrees. Okay, now that I know B is 77 and A is 60, what's 60 plus 77? 137. If you subtract 137 from 180, you get 43, I believe. So I think C is 43 degrees. So now again, I'm going to do A over sine A, but this time I'm going to use C over sine C. Again, we'll fill these in. You need your calculators for these problems. Side A is 16. Angle A was 60 degrees. Side C, we don't know, but we do know angle C to be 43 degrees. Cross multiply 16 times the sine of 43 degrees equals C times the sine of 60 degrees. Now I'm going to divide by the sine of 60 degrees. If I divide by the sine of 60 degrees, it leaves me with C. At this point, it becomes an approximation when I punch it in my calculator. 16 times sine of 43. Then you want to divide that by the sine of 60. And I think I get 12.6000. So I would round that to the 10th and call it 12.6. Again, the angles are to the nearest degree and sides are to the nearest tenth. Is the biggest side opposite the biggest angle? Is the smallest side opposite the smallest angle? So I believe we have 25 solved correctly.